Cool. All right. So let's start off by talking about rational equations. Now, let me figure out all right. So solving rational equations. Now, the thing to keep in mind about rational equations is that these are just equations that contain fractions. When you see the word rational, that means we're talking about things related to ratios, which means we're talking about which means we're talking about things that can be written as fractions. So we've already seen some of these guys before as we've been reviewing the concepts that we have here in the first half of college algebra. One of the first things we're going to talk about here is proportions. Okay, so a proportion is just, two equal fractions. Okay, so a proportion looks like this. A over B is equal to C over D. And in a proportion, the cross products are equal. In a proportion, the cross products are equal. So that means these guys right here, these are our cross products. Okay, so that means that the cross product of A times D is equal to the other cross product of B times C. Okay, A and D are called the extremes, B and C are called the means here in this proportion. So in a proportion, we say that the cross products are equal. Okay, and once we do that, we go from having two fractions that are equal to just having a regular equation. For example, I don't think that's helping at all. So for example, if I ask you to solve this, and I say x plus 4 over 7 is equal to 3x minus 5 divided by 6. So what we have here is a proportion, and what we're saying in this proportion is that cross products are going to be equal. So that means this cross product, that would be the product of 6 times x plus 4, this is supposed to equal the other cross product, which is going to be 7 times 3x minus 5. And what we do is we go from having an equation that has two fractions into an equation that doesn't have any fractions. Okay? And so now we just solve this by distributing. So we get 6x plus 24 is equal to 21x minus 35. All right, and it's just a normal linear equation for us to solve after this. So first things first is I would move the variable terms to be on the same side, so I'm going to subtract 6x. Now, I don't have to subtract 6x, but that's what I'm going to choose to do because that's going to give me a positive coefficient for my x term. Now, once I do that, we have 24 is equal to 15x minus 35. And now we move the 35 to the other side because this is just a small, nice, linear equation. Okay, so 24 plus 35 is 61. And this equals 15x. Oops, excuse me. And now we take the last step for getting x by itself, which is to divide both sides of the equation by 15. All right, so we see here those 15s reduce away, and x is equal to 61 over 15. You do your best to try to simplify that, but there's nothing else that we can do. 61 is prime, so it has no factors in common with 15. And so that's it. 59? It is 59. I'm not paying attention today. I don't know what I'm seeing. We're just going to pretend this didn't happen, right? And me, casually, you know what? And so as we were saying, yes, 24 plus 35 is 59, right? I don't know why guy said it was 61. I mean, clearly it's 59, right? Well, I think I must be having one of those days. See, it's different whenever I don't have you guys there to always correct me and make sure that I'm doing things right. Sometimes I get numbers stuck in my head and I can't get them out. So, yeah, I don't even know what I was seeing there. What was I seeing? Oh man, maybe I saw the 6 up here with the 5. I don't even know. No clue. How you doing? Good to see you here, Crit. Hopefully you didn't see the big snafu that I just made because I wasn't paying attention. Maybe I'm going to change my name to Not Math Man because I don't know what I'm doing these days. All right. So let's try. The mathing is, you know what? I have my good days and my bad days. I've got a feeling that 3 p.m. in the afternoon is not the best time for me. But I'm just trying to make sure that I stay out of everybody's hair so that I can do the streaming. Well, you know, if you didn't catch the silliness that just happened, you can always catch it later on YouTube. You know what? I think it's just everything is just getting kind of crazy, especially realizing that I'm not going to be seeing any people for over a month. All right, so let's take this guy right here. Another proportion. Yes, quadratic equations. Quadratic. Oh, are you looking ahead? Advanced math? So whenever I recognize that I have a proportion, I want to set the cross products equal. Okay? So that means the cross product for x plus 6 times x minus 4 is supposed to equal the other cross product of 3 times 8. Wait, the title of the stream is... It shouldn't be that way. Oh, good grief. Alright, I guess I didn't click update, so it shouldn't say quadratic equations. It should say solving rational and radical equations. Again, I'm still working at the kinks in all of this, and I know that you can appreciate that. So, again, these cross products are equal. Please don't say cross multiply. You guys have been in my class. You know how I feel about that. It's the cross products that are equal. And from here, we just have to solve this. But we can't really know what to do until we multiply everything out. So, over here we have the product of two binomials, so we just need to FOIL. So x times x is x squared. X times negative 4 is negative 4x. And now distribute the 6. So plus 6x, and then 6 times negative 4 is negative 24. Okay? Unless I'm making another mistake, I feel like the math is all off in my head. All right. On the right side of the equation, we have 3 times 8, and we get 24, right? Shouldn't be too bad. Now, once you've done the cross products and you set these guys equal to each other, you want to evaluate what type of equation you have left over. Most of the equations that we come across will either be linear, like we had for the last example, or they're going to be quadratic or some kind of polynomial equation. At the very beginning, we don't necessarily know what it's going to be until we get rid of the fractions. So in this problem, the fractions are the bad guys that we're going to eliminate. Later on in the stream, we're going to be seeing radical equations. So these are going to be equations that have square roots in them. And it's going to be our job to undo the square root, to get rid of the radical. All right. So now that we have this, we recognize that since we have a square, this is quadratic. And we have a bunch of terms that contain x, so we're going to try to factor in order to solve this. Please don't go straight to the quadratic formula. We talked about that yesterday. So we need to bring everything to the same side, so I'm just going to subtract 24 to move things from the right side to the left. So these guys go away. Combine like terms. So we have x squared minus 4x plus 6x, combine those like terms, we get plus 2x. Please make sure you understand that these 24s do not reduce away. This is minus 24 and another minus 24. That means a total loss of 48. Also remember that this is equal to 0 on the right side. Well, thank you for noticing the handwriting. I've worked very hard to get this far. And you know what? I've seen a lot of handwriting over the years, so I'm sure it wouldn't be that bad, especially from someone who likes to write so well. All right. So here, let's try to factor this. This is just x squared. So we have the expectation that if this is going to factor, it's going to break down as x times x. And the trick that we were playing as we were reviewing factoring is that we're going to be looking for factors of 48 that can subtract to give us 2. So factors of 48 that subtract to 2, that have a difference of 2, will be 8 and 6. Now, you guys know me. You know that I will take care of the signs here at the end. I don't need to worry about it just yet. Well, except now I do, right? So the first part was making sure we understand how we get the numbers 8 and 6, and now it's about the signs. The middle term is positive, so we want to make sure that the larger of these two numbers matches that sign, so it's going to be positive as well. But in order to get a negative 48 whenever I multiply, that needs to be a negative 6. And as we finish solving this, use that zero factor theorem, so x is equal to negative 8, or from here, x is equal to positive 6. Now, before you say, okay, great, these are the answers and let's box them, we need to make sure that we go back to the original problem and identify some things. You may have forgotten this about rational expressions, but there are things called restricted values that we have to watch out for. Remember that when we talk about what it means to be a restricted value, that means any replacement of the variable that would cause the denominator to equal 0. Because if the denominator equals 0, then your expression is undefined. Now over here, my denominator is 3, and that guy can't change. He's still just going to be 3. But this one, x minus 4 could equal 0 when x is equal to 4. Now the reason we identify these restricted values is because we can't have that as a restricted value. Okay, that's going to throw things off for us. So if you look at our two answers, neither one of these is equal to 4. And as long as we've done the math correctly, which is kind of hit or miss today, then both of these guys should work out. And we shouldn't have any issues with that. Okay? Now, I need to check something real quick on this. And that's what I was afraid of. All right, give me just a second. Okay. I guess I'm going to have to keep changing those settings every time that I open up this program so that it's not doing the autofocus the whole time, because it just needs to be focused on the paper. So sorry about that. All right. Let's do another one. All right. So let's tackle 2x plus 3 over 16 is equal to negative 1 over 2x minus 7. Okay? So it's pretty much like the last problem that we did. You've got one fraction equal to another fraction, so that means that we have a proportion, and as we have been saying, that means that the cross products are going to be equal. So that means that that cross product of the extremes, so that's 2x plus 3 times 2x minus 7, is supposed to equal the product of the means. That's going to be these guys right here. So that's going to be 16 times negative 1. All right, so we go from having a fraction, having two fractions, to not having any fractions. And again, that's the key thing with a lot of these equations, is that you're trying to get rid of the problem, whether it's absolute value, fractions, radicals. You get rid of those guys by legitimate means, and you evaluate what's left over. You examine what we have. Okay, so right here I need to multiply everything. So FOIL, 2x times 2x is 4x squared. 2x times negative 7 is minus 14x. Then go to the inside. 3 times 2x is 6x. 3 times negative 7 is negative 21. And on the right side we have negative 16. And so now we're going to move 16 to the other side by adding 16. Remember, show each step, use colors, make it vibrant, make it easier for you to see. Alright, so we have 4x squared. Combining these two terms right here gives me, oh man, so I'm getting nervous. I'm afraid I'm going to make a mistake. Negative 14x plus 6x is a minus 8x. Negative 21 plus 16 is minus 5. Okay? And then from here, it's just going to be a matter of trying to factor this guy. Oh man, this lead coefficient is not 1, so what are we going to do? I think we should do the AC method. Okay? And so scooting over here, the AC method, so A times C, we're going to say we've got 4 times 5, and that equals 20. And now we want to look at the 20 and see if we can find factors that are going to subtract to give us 8. And if we can find the factors of 20 that subtract to give us 8, that's how we're going to end up splitting the middle term. So it shouldn't take us too long to arrive at the two numbers. 2 times 10. 2 times 10 will equal 20, and they have a difference of 8. So let's see how we use those numbers to split up this middle term. Now, if you don't want to do it in the middle of the problem, you can just do it off to the side. Have a piece of scratch paper where you do the factorization. So minus 8x is going to be replaced with a 2 and a 10. So that's going to be 2x and 10x. But we have to pay attention to our signs. Okay? So in order to still get a negative 8x at the end, the larger number must be negative, and we know that we must have a positive 2 here, so that altogether we end up with a negative 8. And now it's just a matter of factoring by grouping. In the first group, the common factor here is 2x. So we factor that out, and we're left with, careful now, 2x plus 1. Okay? It's easy to forget about the 2x here, but remember, 2 divided by 2 is 1, not 0, so you still have to have something there. Minus, okay? So minus, and the common factor in that group between 10 and 5 is 5. So we're going to factor out negative 5, and again we're going to be left with 2x plus 1. And so now we can finish the factoring by grouping since these guys are exactly the same. And so now that becomes 2x plus 1 times what 2x plus 1 was connected to, which was 2x and minus 5. Okay. All right, so we've gotten through the factoring part. Let's just recap what we have up to this point. We recognize that we have a proportion, we set the cross products equal to each other, and we just do some arithmetic to get everybody to the same side of the equation. Since this guy's quadratic, we factor. We like to use the AC method and split up the middle term so that we can factor by grouping. Finish the factorization, and now we can finish and use that zero factor theorem. So from here, that means x is going to equal, we've got to subtract 1 and divide by 2, or from here, x is equal to, we add 5 and divide by 2. You know, I was about to box these guys, but I got to make sure that we take care of something first. We need to make sure that we address the restricted value or values that are here. Now, 16 is not going to give you a restricted value because it's just a constant, and it could never equal 0. But 2x minus 7 could equal 0, and it could equal 0 at positive 7 halves. If you're not sure how to come up with a restricted value, just imagine that you were taking this guy and you're setting it equal to 0. How would you get x by itself? You would add 7 divided by 2. So our restricted value is 7 halves, but I do not see that here among these potential solutions. So both of these guys should work, and we should not have any problems whatsoever. Okay? Just like that. Now, we can check these with the calculator. It shouldn't be too hard to do that. Or you can just trust me for right now. Okay? So these are the nice easy ones. These are the guys where you can use proportions or we have a proportion and use cross products to finish them. Sometimes things are a little bit more complex. For example, if I take 7 divided by x plus 8 minus 3 over x plus 2, and this is equal to x plus 5 divided by x squared plus 10x plus 16. Okay, it does look more complicated, but it really isn't that bad. When you have these problems with big, nastier looking denominators like this, your job here, and the best thing for you to do, is to go ahead and factor everything. See, x plus 8 and x plus 2 cannot factor, but this guy can, and he factors as x plus 8 times x plus 2. Now, what we're going to do here is we're going to make sure that every fraction that every piece here has the exact same denominator. And the reason for that is a little statement that we would have said quite a while ago, which is this. Okay, we say that if A over C is equal to B over C, okay, so if you have two fractions that are equal and they have the same denominator, then our conclusion is that those numerators must be equal. And so what we're going to do here is we're going to make sure that everybody has the exact same denominator. And if everybody has the same factors in their denominators, we can just ignore the denominators and focus on the numerators. So if I look here at x plus 8, I want that denominator to include both of these factors. Now right now he has x plus 8, but he needs the x plus 2. So I'm going to put in the missing factor of x plus 2 in that denominator. Now when I put in x plus 2 in that denominator, that changes the problem unless I also multiply the numerator times x plus 2. So see, now we've maintained balance for this particular fraction. By multiplying times x plus 2 over x plus 2, I'm really just multiplying times 1. So I'm not changing the fraction, I may be changing the way that it looks, but I don't change its meaning. Now for this middle fraction, you have x plus 2. This guy already has x plus 2. So you see that x plus 2 is missing the factor of x plus 8. So just like I did for the first fraction, I put in that missing factor of x plus 8. Just like that. But we got to put it in the numerator as well. You can't just do it to part of it, you have to do it to the whole thing. And now observe what we have. These two factors are the same as those two factors, are the same as these two factors. So all of the denominators are exactly the same. So we need to now rewrite our equation based purely off of the numerators. I have a lot of students that tend to multiply this as they go to the next step, but I say just hold on. Rewrite this first. So 7 times x plus 2 minus 3 times x plus 8. Now notice on the right side, I didn't do anything with the x plus 5. That guy's still going to be x plus 5 because that fraction over there wasn't missing anything. And now that we don't have any fractions, we just multiply out, see what kind of equation we have, and solve it. So let's distribute. We get 7x plus 14. Make sure you pay attention to this negative here. You are distributing negative 3 into here, so pay very close attention to your signs. So it's minus 3x. Negative 3 times 8 is negative 24. And then we get x plus 5 on the right side because I didn't have to do anything to that. Before we go into the next step, you want to identify what kind of equation you have. Do you see any powers here? Well, no, these guys are all just x to the first. So that means that we have a linear equation. And if it's linear, we know that at some point we're going to get all of the variables to one side and all of the constants to the other side. Okay, that's just how we do it. Now you don't have to do it that way, but that really is the best way for us. Now before we do that, let's go ahead and take a few moments to simplify and clean up the left side of the equation. So 7x minus 3x is 4x, plus 14 minus 24 is negative 10. And then x plus 5, there was nothing to simplify, so we'll just bring it down like that. Again, it's a linear equation. Let's get all of the variables to one side. So here, I would move all of my all of the variable terms to the left by subtracting x. And as I'm moving that to the left, I'm going to add the 10 so I can move my constants to the right side. That goes away to give me 0. And now 3x equals 15. Divide both sides by 3. And x equals 5. Okay? So once we get down to the linear equation, it really isn't that bad, or at least it shouldn't be that bad. But we need to make sure we pay attention to our restricted values. Looking back at the original equation, let's identify what values that we could not have had for a solution. And that's really just by taking those denominators and setting them equal to 0. So here, what would make this guy equal to 0? Well, that would be -8. What would make x plus 2 equal 0? That's -2. So as long as we don't have these guys showing up as solutions, then what we have is going to be the solution. And that's it. It's just x equals 5. Hopefully that doesn't seem too bad. You put in the missing factors, you rewrite the numerators, and then you work the equation from there. So the big idea is to be able to rework your problem so you don't have fractions. All right, let's do another one that's very similar to that. Yeah, you may see me looking off to the side for the problems, because these problems are not the kind that you just make up off the top of your head. At least not for me. Because I need these problems to do very special things. Well, for you. Remember, no matter how intimidating a problem looks, don't be scared. Take it one piece at a time. Take it one piece at a time and figure out what you can do. And sometimes you just have to try something. It may not work out, but you just got to try. There have been a lot of times in my life with math where I didn't know what to do, so I would try one way. If that didn't work, I would try a different way, but I would try something. Don't quit. So our job here is to make sure that everybody has the same denominator. And in order to easily get that same denominator, we have to factor everything. Okay? So factor all of these denominators first. That way you can see what factors you're supposed to be working with. So for this first denominator, we need to find factors of 10 that subtract to 3. So this guy is going to factor as x plus 5 times x minus 2. For the middle guy, we need factors of 20 that subtract to 1. And those factors would be 5 and 4. So that's x plus 5 times x minus 4. And at this point, you're going to start to see these factors repeat. If these two factors are completely different from those two factors, are completely different from these guys, we might be having a problem with our signs or just not factoring correctly. We should have some factors that are already in common. So here, factors of 8 that add to 6. That's going to be 4 and 2. So x minus 4 and x minus 2. So we're now at the point where we're putting in the missing factors. In this first factorization, look at all these other factorizations and see if they have something that this guy's missing. And you'll see that what this first fraction is missing is the factor x minus 4. So put in the factor of x minus 4 in the denominator and in the numerator. And then we'll move on to the middle fraction. What factor is missing here? Well, if you compare it just to the first one, he's missing x minus 2, and he's also missing the x minus 2 from here. So, yeah, that's what's missing. The factor of x minus 2. Okay? And now we go on to the last fraction. And the last fraction is missing the factor that everybody else has, which is x plus 5. Okay? And so now that every fraction has the same set of factors, we all have that common denominator, we can now rewrite our equation based just on those numerators. So that's what we're going to do. We're just going to copy everything down. Just as we see it. Don't distribute yet. So x times x minus 4. Then you've got plus 9 times x minus 2. And this is equal to 2 times x plus 5. Take that extra time to write that step instead of trying to distribute everything as you go to the next line. I've had a lot of students distribute incorrectly. They've made mistakes with signs, so take your time. Now we want to distribute to see what kind of equation we have. All right, so distribute, we get x squared minus 4x. Don't forget about the x here. Plus, so positive 9 times x, and times negative 2, so that's negative 18, equals 2x plus distribute, and we get 10. It's the little things that will get you. Now before I go on, I want to make sure we understand that we have x squared, which means this guy is a polynomial function more than just a linear polynomial equation, excuse me. So it's more than a linear equation. So our expectation is that we're going to get everybody to the same side of the equation, set equal to 0, and then solve it from there. You know what? Let's be on the safe side here. Let's go ahead and combine like terms. So we have x squared plus 5x minus 18. Now you might be asking, can you go ahead and move these two terms over before you combine like terms? Yeah, you can do that. I'm just trying to play it safe here. All right. So now we're going to move those two terms over. So I want to subtract 2x on both sides, and I want to subtract 10 on both sides. So moving both of these terms from the right to the left so that I can use the zero factor theorem. All right, so that's 0 on the right over here. X squared plus 3x minus 28 is equal to 0. A nice, fairly simple trinomial for us to solve. Factor. Okay, so when we factor this, we factor and this guy becomes x plus 7 times x minus 4. These are the factors of 28 that we'll subtract to 3. Make sure that you get the right signs. And from here, when you solve this, x is equal to negative 7. And here, x is equal to positive 4. Before we box anything, make sure that you have identified any and all restricted values. Think about what would be bad to plug in for x. What would cause you to have a factor that becomes 0? Well, a value of x equals negative 5 would make that equal to 0. If you plugged in a positive 2 here, or if you plugged in a positive 4 here, any of these three values would cause us problems if we try to go back and check. Oh, wait a minute. X equals 4 is a restricted value. So here's what that means. That means that this guy is what we call this is an extraneous solution. What we need to understand is that we didn't do anything wrong. X equals negative 7 and x equals 4 are perfectly fine solutions to this equation, to this equation, to this one, and this one. However, we have to go back to the original equation. When we had all these fractions and then we didn't have them, there was a certain assumption that we were making. And that assumption was that we were going to be avoiding restricted values, and we would never plug those guys in or have them as solutions. But this equation down here doesn't know that. This equation down here thinks, I'm just a quadratic equation. I'm going to have two solutions. But you always go back to his original state, right? This is not the final form. There's an extra form. Okay? But you always go back and you check against the original form. So x equals 4 is extraneous, and we would not include that. X equals -7 is the solution, and there's only one solution. Now, I don't want you to think that for these equations there's only going to be one solution. We had, a second ago, we had two different problems that had two different solutions for it. But they didn't have issues with restricted values. There was no contradiction there. So this one did, so we say it's an extraneous solution. Or on a test or a quiz or wherever you see this, you need to somehow indicate that you understand that this guy is not going to work and that this is the only one true solution. Excuse me. All right. Well, these were rational equations. Okay. Let's talk about radical equations. Now, with radical equations, these are equations that somehow, in some form, contain a radical. Now, in order for us to solve radical equations, we have to understand the power property. All right, so let's write that out. What does the power property mean? What does it say? All right, so the power property says this. It says that all solutions to the equation A equals B. So all solutions to that. These solutions can be found. They can be found among solutions to A to the n equals B to the n. So basically what this is saying is that we can raise both sides of an equation to the same power, and the solutions we get from that equation will contain any solutions that you would have had from the original. It may contain extra solutions, but it's not going to be missing out on any solutions. Okay? So let's talk about the steps for solving. To solve an equation that contains a radical. All right, your first step is to isolate a radical. You may have multiple radicals. Your job is to get one of those guys by itself. Find the more complicated one and isolate it. Step 2 is to apply the power property that we just talked about. Raise both sides to the same power and use a power that's going to undo that particular radical. That means if you have a square root, you use a square to undo the square root. If you have a cube root, you're going to use the third power to undo that. Basically, the power that you use to raise both sides of an equation is going to be a number, a value that matches the index of the radical. So that what's in that little nook, if you see a fifth root, you raise both sides to the fifth power. It's that simple. After you apply the power property, you then repeat steps 1 and 2 if a radical remains. Now, this shouldn't be a problem if you only have one radical to begin with, but if you have multiple radicals, a lot of times you have to go back through and redo this process. Step 4 is to solve the resulting equation. That means that if you get rid of your radical and you have something linear, you solve the linear equation. If it's quadratic or a polynomial, you solve that polynomial equation. Just like we have the rational equations. When they're big fractions, we didn't really know what we were going to have at the end, so we got rid of the fractions. When you have radicals, your first job is to get rid of the radical, and then you can figure out where you need to go after that. And finally, our last step is that you check solutions into the original equation. Check your solutions into the original equation. Make sure that you don't have anything that is extraneous, something that's going to give you a problem, and we should be okay. Now, these problems really don't get to be too complicated. There are a few that are kind of messy, but all in all, they're really not too terribly bad. So if I ask you to solve, let's keep it nice and simple. Let's take the square root of x plus 7 equals 5. If you go through the steps here, step 1 says to isolate a radical. Well, that's already done. Step 2 says to apply the power property, and what we just got done saying is that you want to make sure you raise both sides of the equation to a power that's going to match the index. So the index here is understood to be a 2 because it's a square root, so we square both sides. Remember, whatever power you use on one side, you have to use on the other side. Maintain balance in your equation. When you square the square root, you're not even going to touch the radicand. The square hits the square root, and these guys just are inverses. They dissolve away, leaving us with what's on the inside, x plus 7, and 5 squared, of course, is 25. Now that the radical is gone, we identify that we have a linear equation, and we solve this just by subtracting 7 on both sides. So x is equal to 25 minus 7 is 18. Take a moment to check your work. Plug 18 back into the original equation. So 18 plus 7 is 25, and the square root of 25 is 5. Yep. So it works out. No problem at all. Let's do another problem here. Let's try the cube root of 2x minus 5 plus 11 equals 14. All right, so to follow the steps that we have above, we need to isolate the radical. And we do that by subtracting 11 on both sides. Okay? So we have the cube root of 2x minus 5 is equal to 3. You have to get the radical completely by itself first before you can do anything with the power property. Now that the radical is by itself, we raise both sides to a power that's going to match the index. See, we're trying to get rid of that cube root, so we cube both sides, like that. When we do, you cube the cube root, so you get the radicand, that's 2x minus 5. On the right side, we get 3 to the third. 3 to the third is 27. And now you have a nice linear equation to finish solving. So add 5 to both sides. And now we have 2x is equal to 32. One more step and we're going to be done. And we divide both sides by 2. 32 divided by 2 is 16. And it's really just a simple exercise of plugging 16 back into the original equation to see that it is a true statement. If I plug in the 16, 2 times 16 is 32. 32 minus 5 is 27. The cube root of 27 is 3, plus 11 is 14. Right? Just like that. So let's try another one. All right. Let me do this real quick. All right. Let's look at x minus 5 is equal to the square root of x plus 1. Now, fortunately for us, the radical is already by itself. There's only one radical. It's there on the right side of the equation. So we can go ahead and use the power property. When you use the power property, you are applying that to both sides of the equation. Yep, thanks for stopping by, Crit. Appreciate that. Catch you later tonight, hope. All right, so you square both sides. You're not squaring each term, but you're squaring each side, and that's very important to us. See, on the right side of the equation, it's pretty nice because when you square the square root, you just have what's left on the inside. It's the left side that tends to give people problems. But we need to remember this. When you square a binomial, it's a special product. That special product will give you a squared plus 2ab plus b squared. Now, if you don't want to remember that special product, you can just remember that to square something, to square x minus 5, you need to do x minus 5 times x minus 5. Okay? But I'm going to use my special product. Because see, this is my a and that's my b. It's almost like completing the square going backwards. So when I square this, I get x squared minus 10x plus 25. Okay? And again, as I'm saying, if you don't like this, you could take x minus 5 squared and just crunch it out. X minus 5 times x minus 5. But I do want you to see that when you square the x, you get x squared. That's the a squared. B is 5, so if you square 5, you get 25. The middle term is doing 2 times the product of a and b. That means if I were to multiply x and negative 5, I get negative 5x. And if I double negative 5x, I get negative 10x. Okay? And you would see the same thing when you FOIL this out. All right, so that's the left side of the equation. When you square the right side, you square the square root, and you're left with x plus 1. And that's it. Nothing much to do there. What you need to understand is that this square root is keeping this guy tied up as one complete unit. So when you square, the square hits the square root first, and it doesn't hit the binomial. So the square and the square root, they go away. They blow up. Over here, the x minus 5 doesn't have that protection, so you actually have to do the squaring, which is why we get something that looks completely different. All right. Once the radicals are gone, we recognize that what we have is something that is quadratic. So let's use that zero factor theorem. So let's move the x from the right to the left, and let's do the same thing with the 1. So let's subtract 1 on both sides, like that. So the 1's are gone, the x's are gone, and now we take care of what we have. Alright, so it's x squared minus 11x plus 24, and that equals 0. Alright? And now that we have this quadratic equation, what are we going to do? We could throw it into the quadratic formula, but I don't think that is the best thing for us. Instead, let's take this and let's try to factor it. Can you find factors of 24 that add to 11? And yeah, we can do that. Because those factors of 24 that add to 11 are 3 and 8. And so we play around with the numbers here and the signs. Both of these guys are going to be negative. So from here, that means x equals 3, or the other option, from x minus 8, means that x is equal to 8. Okay? Now, as much as we would like to just take these guys and roll with it and say that's it, that's the end of it, we need to make sure that we go back and we check our work, because we're going to run into some issues, I think. What issues? Well, let's see. Off to the side here, let's check x equals 3. When I check x equals 3, I plug it in, and I want to see, does 3 minus 5 equal the square root of 3 plus 1, like this? Alright, so 3 minus 5 is negative 2. The square root of 3 plus 1, that becomes the square root of 4. And this is where we have issues, because negative 2 does not equal 2. See, remember when we have the square root sign, that is the principle of the positive square root. I know that 4 has 2 square roots, but when I use this sign, I'm only getting the positive one. And these guys are not equal. So this guy right here is another example of an extraneous solution. It doesn't work. Well, you know what? We better check the other guy. Alright. So let's check x is equal to 8. Plug in 8 into my original equation. So 8 minus 5, I want to see, does that equal the square root of 8 plus 1? 8 minus 5 is 3. Inside the square root we get 9. And we can see that 3 equals 3. And now that's a true statement. So x equals 8 is our solution. And we only have one solution here. I mean, it's possible to have more than one. But for this one, it's only that solution. All right. Let's try one more problem. The square root of x minus 1 is equal to the square root of the quantity x minus 5. Now what's different with this problem compared to the other ones is that we have multiple radicals in the same equation. So the steps say to get one of these guys by itself, usually the more complicated guy, and that would be this one. I think getting him by himself is what we should do, and he is. So now we use that power property. These guys are all just square roots. So squaring both sides is the thing to do. Here, this is going to be messy. Unless you think about this as A and B and use that special product that we mentioned above. Okay, so this is something that's of the form A plus B squared. And the form above says that the first piece is going to be this guy squared. So if I square the square root, I just get x. The middle piece is supposed to be plus 2 times A, which is the square root of x, times B, which is negative 1. So basically you have this big product all smashed together. Plus, you have B squared. Now, let me rewrite this. So that's A squared, 2AB plus B is negative 1 squared. Okay, notice how this lines up with the formula. A squared plus 2 times A times B plus B squared. And we just work this out. I'll get to the right side here in just a moment. We haven't forgotten him. When you square the square root, you get x. 2 times negative 1 gives me negative 2. But that negative 2 can't really interact with the square root other than being a coefficient for that term. And then negative 1 squared is a positive 1, so just plus 1 like that. So that's how you use that special product to square that. Again, you can also do this as the square root of x minus 1 times the square root of x minus 1. It's going to be a little bit more complicated, but it's still going to be the same thing. On the right side, we don't have complications because the square hits the square root, and we are left with x minus 5. So just bring that guy down. So the steps say to use the power property, and if a radical remains, you've got to go back to step 1. Which means isolate a radical and use the power property again. So here's my radical. We're going to get this guy by itself by subtracting x. Goodbye, x. Subtract 1. Goodbye, 1. So now I have negative 2 times the square root of x is equal to, let's see, these guys become 0. That's nice. Negative 5 minus 1 is negative 6. Do not use the power property yet. We don't have the radical completely by itself because of the coefficient here of negative 2. So I'm going to divide both of these by negative 2. And let's see what we get. So this is just the square root of x. That equals positive 3. Now we use that power property to get rid of the radical. Okay, so we got the radical, we had another radical isolated, use that power property, square both sides, x on the left, 3 squared is 9. Now it looks like this looks like a pretty nice answer, so let's check just to make sure. Alright, so off to the side we're going to check to make sure that x equals 9 does work. Now remember, when you check this, you check it into the original equation. So all the way back up here, I want to see, does the square root of 9 minus 1 equal the square root of the quantity 9 minus 5? Okay, replace the x's with 9. Let's check it out. The square root of 9 is 3. On the right side, we get the square root of 9 minus 5, which is 4. 3 minus 1 is 2. And the square root of 4 is also 2. So that checks out, which means x equals 9 is my solution. Everything checked out. We see that it checks out. And now we can be happy, right? Now, I know that was kind of a long problem for us to do. A lot of different steps there, especially when you had to square with the square roots here on the left side. But it's going to be okay. We got through it piece by piece, step by step. Now, the stuff that we're going to see tomorrow is still going to be an application of the power property. We're going to see it used in a slightly different way. We are still going to be raising both sides of the equation to a power. There are going to be fractions involved. And then we're going to look at solving equations that are quadratic in nature. We've already done one of those before. We're just going to be doing a lot more of those guys. Okay? So, hope that you stick around and you stop by tomorrow.